Yes, hello. In this video, we are going to talk about acids and bases. This is especially for IGCSE chemistry. So let's start. See, measuring acidity and alkalinity. So as you can check it out, acids, they have a pH less than 7. For example, hydrochloric acid, vinegar, or rainwater, they have a pH less than 7. And neutral solution have a pH exactly 7, for example pure water, blood, or milk. Then alkaline solution which has a pH greater than 7, for example you have baking soda, ammonia, and sodium hydroxides which has a pH more than 7. Now move to the next slide. Yeah, acids. What are acids? How you define acids? So acids are the like substances that produces hydrogen ion when dissolved in water. Like few common acids which we have is HCl or sulfuric acid and nitric acid. So when these acids, when we add it in water, they produce H plus ions. What are their general properties? They have a pH less than 7. Their test is sour, and they turn litmus paper, blue litmus paper, in red color. They react with metals and they produce hydrogen gas. They are corrosive, like they can damage our skin, especially if they are concentrated. Bases and alkalis. So, simple definition of base that reacts with an acid to form a salt and water. This is called as neutralization reaction as well. Then what is the difference between base and alkali? So the main difference is alkalis, or the bases which dissolve in water, we call them as a alkali, or otherwise we can call them as a base. Common alkalis are like sodium hydroxide, potassium hydroxide, because they dissolve in water, or ammonia. What is their property? So they have a pH greater than 7. uh, what their test: bitter test and soapy feel. And they turn litmus paper. So how we can litmus paper, red litmus paper turns blue. They react with acid, we called it as a neutralization reaction. Again, they are corrosive if they are concentrated. For example, NaOH can cause sour burns. Indicators. So right now here we have indicators. So for example, litmus paper. So in acid it is in red color, but in alkali it's blue. Phenolphthalein in acid solution is colorless, while in alkali it's pink. Universal indicator shows red whenever pH is 1 to 3. Then from 4 to 6 pH range, its color is orange or yellow. If pH is 7, it's a green, and if pH is 8 to 10, it's a blue, and from 11 to 14, if pH is, its color is violet. Now methyl orange in acid, its color is red. In alkali, it is yellow. Move to next slide. Yeah, so in this slide, we are going to talk about reactions of acids. So as you can see, there are four reactions. First one is acid plus metal oxide, or first one is this: acid plus metal will give you salt and hydrogen gas. For example, is zinc and sulfuric acid will give you zinc sulfate and hydrogen gas. Next one is acid plus metal oxide will give you salt and water. Then acid plus metal carbonate, or sorry, metal hydroxide like NaOH and HCl will give you salt and water. And the finally you have acid plus metal carbonate will give you salt, water, and carbon dioxide. And there is a key test for hydrogen gas and carbon dioxide gas. So hydrogen gas will give you burning splint produces a squeaky pop sound, while carbon dioxide gas turns lime water milky. Yeah, making salts. So, for example, if you have a if you are using acid HCl, so you will end up with salt named chloride. The another one is if you are using acid H2SO4, then you are going to end with salt named sulfate. Nitric acid will end up with nitrate, while phosphoric acid is going to end up with phosphate. So methods for making salts. So solid plus acid. So add excess base or metal to acid, filter off excess, and evaporate to crystallize. Titration is used for soluble salts, exact volumes used, no excess. So evaporate to crystallize. Mix two solution in soluble salt forms, precipitate out, filter and dry it. Another we have is acid base titration. So its a purpose is to find out the exact volume of one solution needed to neutralize another one. It determines by concentration technique or key terms endpoint. So there is an indicator which show you color change while doing the titration. What are the steps involved in it? So fill the burette with I can say either acid or base. We can say we can fill it with base or alkali, then pipette out measure volume of acid into a conical flask, add a few drops of indicator, then slowly add base into acid, and then swirling the flask constantly and stop at the end point. And there is a whenever there is a color change, that's your end point. So now next we have a strong or weak acids. As you can see in the slide, strong acids they dissociate completely. They have a lower pH and they have a higher conductivity. Examples are like H2SO4, HCl or HNO3. While weak acids they partially dissociate. Example is acetic acid. They have a higher pH, lower conductivity, reacts more slowly with metal carbonates. Now, yes, so like as you have to remember this strong acid or weak acid in terms of their ionization. So strong acids they dissociate completely. Yeah. Now common command words. So like state, describe, explain, and identify. Okay, so exam tip. So first one is alkali, which dissolve in water. So all alkalis are basic, but all bases are not alkali because those alkali, those base who dissolve in water, we call them as alkali. So whenever trap 2 is whenever there is a reaction between metal carbonate and acid, there is a production of carbon dioxide, not just only salt and water. So yeah, there's another trap 3, strong and concentrated. So whenever we say strong, it means fully ionized. Yeah, and trap 4 is using wrong indicator for titration. So whenever we use most of acid base titration, so we use indicators like phenolphthalein or methyl orange and never any universal indicator. That's it from this video.